So today we're going to talk about natural base, or also known as E. Okay, so if you look at your calculators, we'll be using calculators today. We've been having more success with the actual calculators than the phone calculator. So if you have a phone calculator, I'd probably get an actual one, just because some of the functions are a little different here. So natural base E, section 7.6 today. Slowly waiting for it to come. The natural logarithmic function f of x equals ln of x. Ln of x is the inverse of the exponential function with the natural base e. So natural log of x is the inverse function of e to the x. Okay, the constant e is an irrational number that is approximated by 2.718. If you type your calculators and hit the function e, it should show up as 2.71828 and continue on. Check to see if you can find E on your calculator. It should be near the log button. If you see the log button, it should be near the log button. If you see an LN button, it should be near the LN button. On the yellow calculators, you want to hit second log and then go to the right, and it should see it. Okay, but if you do E, and if it makes you put an exponent in, put E to the first power. Okay, if you do that, E to the first power should come up as 2.71828 and continue on and on and on. Alright, so now that everybody's found E on their calculator, we're going to be simplifying some logarithmic or natural logarithmic functions here. Alright, so E is the same thing as log. Basically, E, or natural log, is the same thing as log base E. That's what ln stands for, log base E. Okay, now when we talk about common logs always have a base of what?
1.
Base of 10. So natural logs have a base of what? E. Natural logs is just common base E. That's kind of the difference on the two. Okay, so we're going to use properties of logarithms to simplify expressions with E or natural log. So simplify natural log of E x plus 2. Essentially, here's what's going to happen now. You pull the exponent to the front. Well, we've been doing that for a while now, simplifying our powers, right? So I have x plus 2 and the natural log of E. The natural log of E is always equal to 1. So what happens there? That basically cancels out. And what's that leave me with? Yeah, x plus 2 is my answer. So we're trying to cancel out. Anytime you see natural log in E, they cancel out and you're left with your answer, kind of. Okay. The other one here is a little bit more difficult here. So if you notice, I have a 4 here. The 4 is in front of the natural log. So where's another way I can put it at? I can put it back as a exponent. So that's like saying e to the natural log of x to the 4th. What happens to the e and the natural log? They
cancel.
And I'm left with
4.
x to the 4th. Yeah. X to the 4th there. Okay, so that's kind of simplifying them. Let's try number 1 here. So simplify each expression. Natural log of e to the negative 6x power. When I have negative 6x power, where am I going to put that at? In the front. So I have negative 6x, natural log of e. What happens to that natural log of e? It. And I'm left with? There's your answer.
So is it literally just cancel out?
Yep. Number 2. I have natural log of e t minus 3. My power comes to the front. So I have t minus 3, natural log of e. Natural log of e is going to?
Cancel.
And I'm left with?
T minus 3. So basically right now your answer is directional.
Kind of, yeah. So 3. 3 is a little bit trickier. Why? Because it has that exponent there. What am I going to do with that 2? I'm going to bring it back as a exponent. So now I have e to the natural log of x squared. E to the natural log are going to?
Cancel.
And I'm left with?
X squared.
4. Tough one here. What's my answer going to be, Maddie? Yeah, it's just 1.8. Because those cancel. What about 5? Natural log of e to the x plus 1. Comes to the front. I get x plus 1. Natural log of e. Cancels. And I'm left with x plus 1. 6 is just like number 3. What am I going to do with that 7? Exponent, so I have e, natural log of x to the 7th. What happens to the e and natural log?
Cancel.
I'm left with x plus x or x to the 7th. Nice work. Try these 6 on your own. Take a couple seconds. Try them out. All right, so let's look at number 7. What's the answer to number 7, Phil? That'd be correct. Would you take your 3 back up there, and then that'd cancel off and get x cubed. Number 8, John?
X plus 1 to the 5th.
X plus 1 to the 5th power. Again, take your power up there, cancel off. Number 9, Maddie? X minus 1, nice job. Number 10, Andy, what'd you get number 10?
3x.
That is 3x. So your x would come up here to the power. Well, there's already a power there, so that's like saying natural log of e to 3x, which then is just 3x. 11, Mono, what do you think about 11? Of x negative 1. How else could I write that? 1 over 5x would be the same way. Nice job. And 12, what do you think about 12, Melody? It is 2x. Number 12 is just like number 10. Your exponent comes back up here where the x is, so it's 2x. Nice work. Last thing I want to talk about today is the natural base e appears in the formula for interest compounded continuously. Okay, so where's the stuff always come in common here? A lot of it comes in with like interest loans and banking and those type of things. Interest compounded continuously is different than just your basic interest or simple interest. Okay, when it talks about compounded continuously, you have to use the formula called PERT. We call that PERT. Nothing's fancy. It spells P-E-R-T, so we say PERT. If you know how to spell, you can get this right every time. I mean, hey. But PERT. P stands for the principal or initial amount. So what's our starting amount?
1.
R is the annual interest rate. And we always write the annual interest rate as a what? You always want to make sure you always write it as a decimal, not a percent. You always want it as a decimal. And then T is the time in years. So what's the total amount of an investment of $2,000 invested at 3% compounded continuously for 5 years? Well, I started with $2,000. 3% as a decimal is 0.03. And then continuously for 5 years. Well, 5 years. So I would plug into my formula 2,000 times E raised to the 0.03 times 5 power. So on your calculators, you type that in. 2,000 times E raised to the 0.03 times 5 power. You should come out with an answer that is approximately $2,323.67. Take a couple seconds and check to see if you can do that. Maddie, did yours work out? Good. Did anybody find that answer on the calculator? Now, anytime we're talking about money, great question here. How many decimals should we always go to when we're talking about money? 2. Why? We're talking about cents. Yeah. It makes sense. There it is. Yeah, never go to 1. Don't ever go to 3. Sometimes they might ask you for the nearest dollar. That's okay. But otherwise, it's nearest dollar or nearest cent always. So let's try number 13 here. What's the total amount for an investment of $500 invested at 4.5% and compounded continuously for 10 years? P is my principal. What's my principal or starting amount here? 500. What's my rate as a decimal? 0.045. And what's my time in years? 10. So I would say PERT, P-E to the R-T. So 500 times E raised to the 0.045 times 10 power. And when you do that to the nearest cent, I get an answer that is approximately what, Maddie? $784.15. So over 10 years there, you made about $284. Nice. Try number 14 on your own now. Take it, same idea. Put the formula into PERT and try it out on your own. So if you were to plug this into our formula, you would have 1,000 times E to the 0.028 times 6. And when we do that, you get approximately, what's my dollar amount here, Andy? 82.94. Nice job. Feel pretty good about that? Great. Here's your assignment.